let's do the demonstration of Docker Compose. We'll take one example. So we will write, we will make, we'll write down the steps that we are going to follow for this. So this is our Docker Compose section. Docker Compose. Okay. And yes. So here, so this application is Python based application. So Python based application and requires a service to be run. So that means it has two applications, or it has two containers to be run. So that is the reason we require Docker Compose to make the communication between those two possible. So let's begin our steps. Our first step is to write a setup server directory, and inside that write server Docker file. Okay. And second step, again set up client directory and write client Docker file as well client Docker file as well as application client.py. And third, so let's make the integration of one application with one container with the other container. Let's make that communication possible using Docker Compose. So let's set up Docker Compose Docker Compose directory and write Docker Compose YAML file. So we have seen what is YAML and what's the difference between JSON and YAML. So the similar format, but it's specific to the Docker Compose. As we know, YAML is domain specific, DSL. So every the format can be used, but it will have their Docker Compose will have their own parameters to be defined. So let's get into the action. Why to wait? So the first step is this. So let's do the Docker. Let's create a directory and then let's write our Docker file. And this is our Docker file. So let me get into our server. Yeah. So clear the screen. So cd home Ubuntu mkdir. This is Docker Compose example Docker Compose x1. So cd Docker Compose x1 ls. So nothing is there in this directory. So now we are going to create the directory, that is, we'll do mkdir, and the first one is server. So you see that server, cd server and ls. Let me create our Docker file for the server. So here it is vim Docker file. and let's type first Docker file as usual from Debian. We are going to take Debian, so by default we'll take a latest tag, then a run apt get update and apt get install our service, that is y and map. That's what our service. Then let's execute command. So saying ncat option L 2000 sleep time and option K, then using exec and bin bash. So bin bash doesn't work, sh is okay, bin cat is also fine. Okay, so if you see that the second command, install the nmap package, this nmap package which provides the ncat program used here, and the third one, run the ncat program by default when starting the image. So let me go with the cat only, so y2 ncat. So let me save this, do wq, and so the L option in that, okay, let me go. So let me do the cat of Docker file, cat Docker file. If you see this option, ncat 2000, the L option 2000 arguments instruct ncat to listen on port 2000, and K option tells it to accept multiple client connections simultaneously and to continue running after clients close their connections. So more clients can connect, no problem. More clients, more connections. So now let's get into that. So the first part is done. The second step has been successfully executed, and the final exec of bin cat will make ncat run bin cat for any incoming connections and forward any data coming over the connection to the running program. So next, build the Docker file with this command. So let's build our Docker file here. So clear the screen. We have the Docker file in it. So let me say docker build option T, and the tag I'm gonna give is kubectl and server tag 1 and dot, because my Docker file is in present directory. So let me execute it. So sending build context to docker daemon 2.048 KB, and it's pulling the Debian, that's a base image, and then so remaining steps are starting building, that's update, apt update is happening, and then package is being installed, and finally you can see that it's successfully built with this image ID, and then it's been tagged with kubectl server v1. Then so the image has been built. Let's cross check the image, docker images. So here you can see that kubectl server, that's it. So now let's get into the slide again. So now you can set up the client image that sends you, that's done. Next, it's time to work on client side. So server is done, the one which services our application, that image has been built. Now what will we do is we will write a Docker file for the client, and then we will build that Docker image, and then we'll also write our Docker client app, that's client.py. So we'll do cd and mkdir This time I'll say client and clear the screen, ls, and cd client ls. Now let me begin with our app first. We will write our app. So the third step is client.py, a simple echo client. So we will use a simple Python program as an echo server client. So in the next listing, so the Docker file for this client is straightforward. It installs Python, adds the client.py file, and then defaults it to run on startup as whatever we write in a code. So this is our code. So it's time to write our application. That's a client.py. It's a Python extension, a Python application. So let me do cd. Okay, let me check pwd. Yeah, let me get into the cd home ubuntu and docker compose ex1. So ls, so cd client ls, let me write vm client.py and put this in insert mode, and this is our code. Import socket times sys, and then this is our loop. A while loop has been used, and let me save this file. Now it's time to write our docker file. Our client application is ready now. So now let's look into the file, a client.py, that's application. So the first one imports the Python packages as needed, and then the second that we have mentioned, s is equals to socket.socket. So this module creates a socket object, and after that use this socket to to connect to the talk to server on port 2000, and send a string with a new line character to the socket, and finally create a buffer of 1024 bytes to receive data and place the data into the data variable when a message is received, and print the received data to standard output, and finally flash the standard output buffer so can you see messages as they come in. And let's close the socket object and then wait 5 seconds and repeat the step. So that's what is our application is gonna do. So now it's time for us to write a docker file, a simple echo client docker file. So let's write that. So we will write, we are inside the client. Yes, I'll write a docker file, insert mode from, again we'll take the Debian and run. As usual we will do apt get update and apt get install option y, and this time it's Python to be installed. Then I want to add that client.py, our application, to the client.py inside the container. Then command, it's time to run our Python app. So / user bin Python, and it should run client.py and close it. Yes, this is our command and this is our argument. So the client.py will be copied. That's it. Let me close this. Save it and close. So with this, our Docker file application is also ready. Now it's time to build the Docker image. So Docker build option T tag, and image name is cube Charan / and this is client dot This is client and dot. So its image is being built, the packages are being downloaded, Python is being installed. So once the installation is done, the client.py has been copied, you could see that, and then command use this command and argument has been copied. When you spin the container, it's gonna do a required. Okay, so all done. So all setup is done. Let's look into this. Setup recover, setup server directory, setup client directory, both has been done. Now let me underline that. So now before we use Docker Compose, what we're gonna do is we will do the same without using Docker Compose, and we'll see what's gonna happen. So to demonstrate the value of Docker Compose, we will first run this container by hand without Docker Compose. For that, we have to get back into the server again. So these are the commands we're gonna use. So clear the screen here. So first let's run, but before that, first we'll run the server. For that, we have to get back into the server. So cd server. Yes, here we have our Docker file. Now let me give Docker a run, and name is echo server, and v, that's a version 1, and detached mode and server is the image. No, that's not our image. Let me copy this first, and we will list the images, and then we will. So Docker images, here you could see the images. So now I will paste the same command so that I can attach. It is server and version 1 tag. So bash server, no such file or directory. Okay, what's wrong? It's clearly. Okay, let me clear the screen. Docker images. Now Docker run name. This is echo server 1. Detached mode image name is this cube Charan server, and version 1, sorry, version 1. That's it. The container has been built. Docker ps, Docker ps option A. Here you could see that the container. So then we will build second container. Docker run rm name, client is the name, and we're going to link this with echo server client and do the talk to the client. Okay, so when you're finished, Control C out of the client and remove the container. So client latest locally. So image name, so image name for us is cube Charan client v1. So it's unable to find the image also. So let me do the Docker images first and copy it directly. That's the best way. Okay, we did not give a tag for this. So it's a latest, it's not v1. That's my mistake. Okay, I'm sorry. But still I'll paste it. By default it will take latest anyway. And now let me execute. So error response from daemon could not get container for echo server. no such container echo server. Yes, we do not have the echo server. We have echo server 1. So echo server 1 is our container. Yeah, let me look into that. Clear the screen. Now it would be much clearer. So image is okay. Echo server 1. Okay, that's an exited state. That's the problem with this kind of uh, to this kind of linking with one to other. So many things can go wrong even in this trivial example. So starting the client first will result in the failure of the application to start. That's what had happened for us. So and sometimes forgetting to remove the containers, so will result in problems when you try to restart, and naming the containers incorrectly will also result in failure. So these kinds of orchestration problems will only increase as your containers and number of containers increases and their architecture gets more sophisticated and more complicated and much complex. So that's the reason we would go for Docker Compose in spite of linking the clients, in spite of linking the containers. So let me remove all these containers. Docker PS option A and Docker RM echo server 1. So it's clear. So Docker PS option A, no container at this moment. Now let's do our Docker Compose cluster. So now let's create our Docker Compose cluster. So Compose helps with this by encapsulating the orchestration of these containers, startup and configuration within a simple text file, managing the nuts and bolts of the startup and shutdown commands for you. So let's basically Compose takes a YAML file. So we will create a new directory, and inside that we are gonna create our Compose file. So cd clear ls, so mkdir. So here I'm gonna say docker compose. Okay, cd docker compose. Now let me do vim, and so the YAML files contents are going to be written in our file. So now the fifth step in this is docker compose.yaml. The docker compose echo server and client YAML file all should be configured into the docker server. Okay, so let's write our docker compose file. So vim docker compose.yaml YAML. So let me begin with services here, and then I'm going to mention both. So you can see that services, and we have two services. One is echo server, second one is client. So echo server image name I am going to give, it is, sorry, I cube Charan, and tag is, okay, image, yeah, latest, and exposed to the port 2000, no issue. Then we have another image, that's a client, and here it's a cube Charan client, and it is v1 tag. So and then links remain same. So let's save this. We have two services here, echo server container 1, client container 2, and let's do wq, and our docker compose file is ready. This is our docker compose file with two services. So the client, the first one in first service, if you see here, we have two sections. The first section, the reference names of the running services are their identifiers. One is echo server and client. These are the identifiers in this case, in this example. Then we have two images that we have mentioned separately. So the first one, each section must define the image used, or either image, or you can build Docker, build an image from Docker file. If it is, if you want to build it, you have to mention the build and then Docker file directory. So here we are using images directly. So each section must define the image used, the client and the server images. So in this case, we have two images, that is client and server. And finally, you have in this case, expose the echo servers port 2000 to other services. And here we have defined the link. So define a link to the echo server. References to talk to within the client will be sent to the echo server, and the mapping is done by setting up the /etc hosts file dynamically in the running container. So the syntax of Docker Compose YAML is fairly easy to grasp. Each service is named on the left and its configuration is stated in an indented section underneath. Each item of configuration has a colon after its name, and attributes of these items are started either on the same line or on the following lines, beginning with the dashes at the same level of indentation. The key item of configuration to understand here is the links within the client definition. These are created in the same way as the Docker run command sets up links. So in fact, most of the Docker commands, most of the Docker command line arguments have direct analogs in the Docker Compose YAML syntax. So we use the image statement in this example to define the image used for each service, but you can also get Docker Compose to rebuild the required image dynamically by defining the path to the Docker file in a build statement. So the Docker Compose will perform the build for you. In that case, if you mention the Docker file directory in the build statement. Now that all the infrastructure is set up and images are built, Docker Compose.yaml file has been written. Now it's time to run the application, and it's pretty easy running the application when all are set. So for that, what we have to give is give a Docker Compose, and that's it. Rest, give Docker Compose and sit back and enjoy what is going to happen. So here it is. Do Docker Compose up. So let's spin the containers together in coordination with each other, and let's see what's going to happen. As here, total we have two containers, and the network between each container has been created. That's the network Docker Compose default. And after that, you can see the echo server one. This is a first container, and client one. This is another container. Both containers has been created, and then the network between the container also has been created. So then attaching Docker Compose client one to the Docker Compose echo server one also has been done. So now the remaining the Python code has been executed. So that's how. Let's cross check the Docker PSA containers. You have the two containers here. So that's how you can spin your containers in coordination with each other. That's how one container can be communicated with, can be made communicate with the other container using Docker Compose up. So now to remove this container, to stop these services, it's very pretty simple. Just say docker -compose down. That's it. The containers has been stopped, and there is no container. There is no container. So the containers has been stopped and removed. So that's how a Docker Compose makes a container orchestration pretty simple. So now what we're going to do is let's push the images into the Docker Hub. So Docker images, we have two images. Let's push them. So Docker login cube and okay, yes, login succeeded. Now let's push Docker push cube and version. I think it's latest. Is it what is that? I'll go with the client first. Yeah, and the tag here we have a latest. Yes, the image is being pushed. Yes, it's successfully pushed to the Docker Hub. Now let's push another image too. So Docker push another image for us here is cube and its server. So last time we have pushed client. So now we're gonna push okay server. That's v1 tag. So it's pushing the Docker server. This time the image is server image that we're pushing into the Docker Hub. So the first layer has been pushed and second layer had to be pushed, and successfully we have pushed both the images into the Docker Hub. So now let's get into the Docker Hub and let's cross check the images. So busy tags, let me get into the repository, and here I should see the images that I have just pushed. And here it is, server and client, and both the images just now pushed, last pushed a few seconds ago, last pushed a minute ago. So that's how our Docker Compose helps and making the things pretty simple, making the complex things into pretty simple. With one command you spin your containers in coordination with each other, in connection with each other, and with one command you stop and remove the containers. That's how a Docker Compose helps us in dealing with the complex and complicated applications so streamlessly and easily.